Hi, my name is Adrian, and I'm a full stack developer. And today I'll be talking about some unusual usages for Docker. Docker is a tool that allows you to containerize your code base and deploy it anywhere. But why Docker? In my third year of university, I first found out about Docker. What interested me so much was to be able to containerize a code base and deploy it anywhere, as well as containerize the development environment to have to prevent any struggle with setup between different developers. But some of the more unusual usages of Docker that I ran into that I will be covering today should be something such as Docker in Docker, GitOps, container registries, stateful management, orchestration, unit testing, and a time machine. Docker in Docker. By running a container in privileged mode, you're able to install the Docker engine inside that container and run the Docker daemon. Alternatively, you can use the officially provided Docker in Docker image. This allows for you to build containerized images within a containerized environment. But what are some of the other use cases for Docker in Docker? Some of these would include GitOps, as well as making changes to the source code of the Docker engine itself. GitOps. Now, by creating an image with Ubuntu as the base, for example, we can install all of our GitOps tools within this container and run all of our GitOps tools there. This, however, can be messy. GitOps tools typically provide officially published images, which we can make usage of instead of using the base Ubuntu image, which would be much neater. For example, we have these two Docker images, Docker files here. On the left-hand side, right-hand side, we can see the image that uses Ubuntu as the base, and you just simply curl an app to install everything. On the image on the left-hand side, we can see that we use officially published images. Now, what are the two differences here, and what are the advantages? Obviously, readability. We can see that the file on the left-hand side is much shorter, as well as the size in the files produced. We can see that the image is produced. We can see that the image on the left-hand side is almost half the size of that of the image on the right. But while both of these do function the exact same thing, we can see that since we're using officially published images, they're purpose-built, so much more efficient at doing what you need it to do. Let's say, for argument's sake, we would like to deploy a Kubernetes cluster within AWS. With this image over here, we can log into the AWS CLI, and we can use Terraform to create our cluster, and then use Docker to build and publish our image to a container registry, and then we can use kubectl to apply our changes to the cluster. Container registries. Now, there are many options out there for container registries, such as Docker Hub, AWS, GitHub, and much, much more. But why not host your own? Using an Artifactory tool such as Sonatype Nexus or JFrog, we can achieve this. Now, what exactly is an Artifactory? Artifactory is a tool that would allow for you to publish things such as Helm charts, pip packages, npm packages, raw files, and Docker images on a privately hosted registry. Now, over here, you can see I've got a locally hosted Artifactory. And over here, you can see that I built a simple Docker image and pushed it here, all hosted within my local machine, all from within a Docker container. But once the Artifactory image gets deleted, this means that all your container registry and all of its images, they're all gone along with it. But this doesn't have to be the case. Through the usage of something such as volumes, you can persist your data between restarts of your container. By mounting the directory inside of the container to your local machine, for example, or using other methods to mount volumes, the data will be persisted. This can be particularly useful in a use case where you would like to host a database locally, and you can point towards the directory that stores database data. Once your image gets restarted, data will persist. Another use case for this would be for volume mounting. For example, with the previously mentioned GitOps example, we can mount our directories, our Terraform directory, directly onto the container. What this means is that any changes made on our local machine to the infrastructure code will reflect inside the container and vice versa. For example, if we were to run a formatter, we would be able to see changes reflected locally inside of our local system. But managing these commands can be very difficult, but not with orchestration. So say, for example, we would like to create a Docker container, but not manage all of the commands, the command arguments that come with it. We can use a tool such as Docker Compose. What this allows for us to do is specify arguments in a Docker Compose YAML file, and allows for us to not have to worry about all of these commands and remembering all these arguments. We just have to simply remember one single command, Docker Compose up. But so it could look something like this, for example. You can see here it just specifies Docker file it's pointing towards, that it's being ran in privileged mode, the volume mounting. All of this done without having to actually remember the command line arguments for any of these, which I personally tend to forget. But this is not all that this can be used for. We can also spin up an entire ecosystem locally, all from within one file. Now, this can be done regularly with regular Docker commands, but it is much easier to manage everything from a single YAML file. This can be used for something such as a POC or even just a local development environment. Another great use case for this would be unit testing. Now, infrastructure for testing can be very expensive typically, and not something clients typically would like to pay for. Also, using pre-existing infrastructure can be risky. So what is a solution here we can use with Docker? We can spin up our entire ecosystem, as previously mentioned, using Docker or Docker Compose. We can run our unit tests and dispose of the environment immediately without having to worry about anything getting affected. For example, if one of the tests were to break, then we could just dispose of the environment and try again. Nothing breaks. But versioning can be a very difficult task when installing things, so we can use Docker as a time machine. Now, when working with a code base, a lot of the time, especially legacy code bases, installing these old versions of languages can be typically very difficult, and you might have to go to the Internet Archives to install an old version of Python or COBOL, for example. Typically, Docker provides, these languages provide officially published images for each version of the language, making it much easier. For example, we can simply set the version Python 2.7 in a Docker file, and whenever anybody clones that repo, we can spin up that Docker file and not have to worry about installing any of this locally and struggling to get the versions of these languages. Another use case would be when you're building a website, you of course may want to make usage of the fanciest, newest JavaScript, but this isn't always a viable option. You always need to make sure that your JavaScript works on all sorts of browsers, old browsers, new browsers, and what one solution would be to install all the different versions of these browsers locally on your machine. This can be very difficult to manage and take up a lot of space on your computer. What you can do is you can use something such as Firefox's images and use old versions of browsers to test your code. So you can simply pull each version of the browser you'd like, test your code, and keep on going, make sure that your JavaScript functions as intended. So how do I use Docker in my daily life, and how you can too? Typically, I like to use Docker for installing all of my tools without having to actually install on my computer, such as installing, as previously mentioned, Helm or any GitOps tool. I really enjoy using it by mounting volumes onto it. Another thing I enjoy using Docker for is if I've found out about a new technology, but I'm still skeptical about it, I like to pull the Docker image, check it out before actually installing it on my computer. This is a great way to use Docker that everybody can do. And also, most importantly, no more hearing. It works on my machine. Thank you.